Okay, so let's get started. Uh, just a second. Okay, so hello, namaste, and welcome everyone. Welcome to this TA session. So today we will be discussing problems related to week 7 of this course. And today we will be mostly discussing about again the topics of today's problem solving session would be in line with what we covered in the last session, that is Gaussian random variable, standard normal distribution, and working with functions of random variables and all those stuff. And additionally, we will touch upon some problems related to chi-square distribution, which will be something which is important in the upcoming part of the lecture series, which is related to chi-square tests and stuff like that. So let me share my screen. Okay, so maybe I will just you know so this is week 7, right? And this is going to be on the lines of what functions of random variables, uh, standard, normal distribution, and then lastly, something on the about chi-square distribution, right? So we will be solving problems on these three topics broadly, and yeah. So let's get started. We'll start with some simple problems, and then I mean we'll see how many problems we are able to solve today. Most probably this will be a short TA session because I have some commitments that I have to fulfill. And yeah, let's see what happens, right? Okay. So let's look at the first problem. So okay, maybe I will just use red color for questions and blue for solutions. So here's the first problem. First problem basically tells you that there are n random variables, right? So there are x1, x2 till n random variables, and each of them and each xi is distributed according to exponential random variable with parameter 1 by mean parameter 1 by beta. Okay. The question basically is that let's say x1 is the min of all x1 till xn. Okay. So basically it's the smallest value. So it's x1, x bracket 1 is another random variable which assumes the smallest value taken by amongst all the values taken by these n random variables. Okay. The question is, what is expected value of x1? What is it? So this is the question. Let's see how to solve this. So whenever so this is something called order statistics, where you have to find the uh, distribution of a random variable which is nth largest or nth smallest, something like that. So this is called something. This is what is something called as order statistics. Nonetheless, the procedure is nothing different. It might look very scary at time, but yeah, it's not that scary. So what is it? So whenever you have to deal with such thing, maybe you should think about, can I solve it using, can I find the distribution of this random variable and then look at the expectation and stuff. So let's look at the distribution. For that, you need to look at the CDF of x sub 1, right? So what is the CDF? It's basically the probability that x sub 1 is less than or equal to some small x, right? This is the CDF. And what is this equal to? This is actually the probability that min of x1 till n is less than equal to some small x. So if I am saying that, uh, okay, okay, so this, I can write this probability as 1 minus the probability of the complement, right? 1 minus the probability that min of x1 till xn is greater than x, some small x, right? Now, what is this probability? This probability that minimum of all the n given random variables is greater than x. So that just means, so if the minimum is greater than some x, that means that each one of these random variables is greater than x. I hope I am clear in this. I will repeat myself. If the minimum, okay, the minimum value of x1, x2 till xn is is greater than x, that means that each one of them has to be greater than x, right? So it's like saying that this is some minimum value, and all the random variables are above this value. So each one of these has to be greater than this, right? So this thing is equal to 1 minus what probability that x1 is greater than x, right? Into, okay, maybe I will take one more step. X2 is greater than x till xn is greater than small x, right? This is what the probability will be. Now, another thing that is given to you, and I think I didn't mention it, they are all IIDs, right? So since they are IID, they are independent, right? So this probability can be written as the product of each one of them, right? Of x2 greater than x until probability of xn greater than x. Now we know that each of them are exponentially distributed, right? So, and the so this probability for a exponential random variable, we know what it is. It's e raised to minus beta x, right? So just look at the CDF uh, uh, of the exponential random variable, right? 1 minus the CDF is what this probability is, okay? And it's the product of all this because all of them are same, and product till just a dummy random variable I going from 1 to n. So this will become what? 1 minus e raised to minus n beta x, okay? This is what the probability will be. Now, so okay, let me write it. Probability that x sub 1 is less than or equal to small x is equal to 1 minus e raised to minus n beta x. Now you should be familiar with this function, because this is the CDF of another exponential random variable, right? With mean parameter 1 by n beta. Okay, so this implies that x sub 1 is again distributed according to a exponential random variable with mean parameter 1 by n beta. Okay, and uh, if that is the case, then that means that expected value of x sub 1 is equal to what? 1 by n beta, right? So I hope this was a simple problem. It just looks scary, but it's not scary. It's not difficult. It's actually easy. You just need to keep your heads open and think of it from a very sort of simple. Just keep your minds open. That's all. Okay. So let us look at second question. This is a simple just definition question. Nonetheless, I will mention it because it might be useful to us. So x1, x2 till xn, these are all IID, right? Standard normal distribution, normal 0, 1. Okay. The question that is asked is what is expected value of summation I going from 1 to n xi square. What is the value of this? And similarly, what is the variance of same thing? Summation xi square I going from 1 to n. What is the value of this? These two things are asked. So for this, you need to remember what is, you need to know this property that if xi, you know, I going from 1 to n, these are if these are normally distributed according to standard normal distribution, right? Then x, then summation xi square, okay, I going from 1 to n. This is actually this follows a chi-square distribution, chi-square distribution with degree of freedom n. Okay, so what is a chi-square distribution? Chi-square distribution looks something. It's a weird expression. I am also writing by looking at the Wikipedia page. It has this form x raised to k by 2 with k degree of freedoms. Okay, x raised to k by 2 minus 1 e raised to minus x by 2 by 2 raised to k by 2 gamma of k by 2. If x is greater than 0, it is 0 otherwise. So yeah, and the things that you need to remember about this distribution is that expected value of x in this case uh, is simply what, if the degree of freedom is n, then the expected value is also n. Okay, and the degree if the degree of freedom is n, then the variance is 2n. You should need to remember this thing, right? So in that case, I'll just write it clearly. So if summation xi square follows a chi-square distribution with degree of freedom n, then using this property, what we can say is that expected value of summation xi square is equal to n, and variance of summation xi square is equal to 2n. That's it. So here it was more of a definition question because you need to remember this property. Sorry, you need to remember this property that if xi's are standard normal, then summation xi square is actually chi-square is distributed according to chi-square distribution with degree of freedom n. N is the number of random variables that you're summing, and hence from there you can simply write that the expected, what is the expected value and the variance, right? It's yeah, kind of simple thing, but yeah, just yeah. Nonetheless I repeated it to just to make sure that we are all on the same page about chi-square distribution, right? So okay, so let us look at third question. So okay, so there's a company. Okay, uh, this company has a basically produces cars. Okay, it manufactures cars, and the cars basically emit some carbon monoxide. Okay, so let x denote the random variable denoting noting the amount of carbon monoxide CO. Okay, we are told that x is actually distributed according to a normal distribution with mean 2.9 and variance 0.4 square. We are told this thing. The question that is asked is if one randomly chooses uh, one of the cars, what is the probability that the carbon monoxide emission uh, of that car from that car is greater than 3.1? This is what is asked. So again, I mean, it's actually a simple thing. If you remember, we did these sort of questions in the last uh, problem session, right? What we need to do here is, convert this into a standard normal distribution. This is a Gaussian distribution, but it's not standard Gaussian. We need to convert this to standard Gaussian and just see how it have see this probability. Okay, so this thing, probability of x greater than 3.1, this is equal to, you just scale, shift and scale basically. Okay, just shift and scale it to according to its mean and variance, that's all. So you just do x minus mean, which is 2.9, divided by its standard deviation, which is 0.4. This thing should be greater than, you do the same thing on the RHS of the inequality by 0.4, right? Then this becomes what? So now after shifting and normalization, this becomes your standard normal distribution. Greater than 3.1 minus 2.9 is 0.2, and 0.2 by 0.4 is half, right? So this is 0.5, and this thing is equal to 1 minus probability of z being less than or equal to 0.5, and this is equal to 1 minus phi of 0.5. So now you can look up the table of standard Gaussian integral, and this apparently comes out to be 0.3085. Okay, so not a tough question, just another question from on the lines of what we had seen last time. Okay, uh, okay, so all right, so let's look at some one question that which is a good question actually, right? Okay, so maybe I'll take it to the next page only. So it's a good question. Maybe you should just listen to this carefully. And it's not a tough question, but still, it's a good question on normal random variable, and yeah. Okay. So let's see. So this is the fourth question. Okay. So what we are told is there are two random variables x and y. Okay, and they are IID. Okay, according to some mean, uh, according to a Gaussian distribution with mean mu and uh, variance 1. Okay, this is given to us. It is also okay, so they are not IID. Okay, so both of them are, they are I, so both of them have uh, same distribution. They have the same marginal distribution. Okay, it is also given to us that the covariance, or not the covariance, the rho, the correlation, right? The correlation is given to us to be rho of x comma y is given to us to be what? 0.5. This is given to us. Okay, so there are two Gaussian random variables and their correlation is given to us by to be 0.5. uh, that means that their covariance is also 0.5 because the variance is 1. Okay, so the normalization is just by 1, so covariance and correlation are same in this case. Another thing that is given to us is that probability that x plus 2y is less than or equal to 3 is equal to probability of 2x minus y greater than equal to 4. This is given to us, and the question that is asked is what is the value of mu. So I will repeat the question. X and Y are two random variable. They are normally the marginals are Gaussian with mean mu and variance 1. Their correlation or covariance function is given to be 0.5, and we are additionally given this condition that probability of x plus 2y less than equal to 3 is equal to probability 2x minus y greater than equal to 4. The question that is asked is what is the value of this mean parameter mu? Okay, so uh, so how do you go about solving this thing? So one tempting thing to do is, you know, find the distribution of these x plus 2y and 2x minus y, because these are again a new random variable. Can we find the distribution of these two random variables? Yeah, I mean, surely we can, right? Because this is just a linear combination of x and y, and we know that x and y are normally Gaussian distributed, and the linear combination of Gaussian distributed random variables is again Gaussian. We know this property for a fact. Similarly, 2x minus y is again a linear combination of x and y, and a linear combination of them would be again Gaussian distributed, right? Uh, so this will again be a Gaussian random variable. The question that, however, that arises is what is the mean and variance of these two random variables? That is easy to find because we can just use the properties of expectations and variance to come up with this. Okay, so let's look at x plus 2y first. Okay, what is the expected value of x plus 2y? This is just expected value of x plus 2 times expected value of y. And we know that this thing is mu plus 2 mu, right? This is equal to 3 mu. Cool. What is the variance of x plus 2y, right? Again, just use the property of variance. This is variance of x plus variance of y plus 2 times covariance of x comma y. So this is a standard formula that you need to remember about the property of sums of variance of sums of random variables. Now this we know is 1, this we know is 1, again 2 times. So okay, so this is 2y, right? So 2 will come out, 2 will come out. I think this is not, 2 is not outside. 2 will just come out here, and this will become 4 times, right? 4 times uh, covariance of x comma y, and this we know is what, 0.5. So this will become what, 2 plus 2. I'm Okay, there is again 2 here. Oh, sorry, I forgot. So if this 2 comes out here, this will become 4, 2 square, right? Okay, so this will become 4 plus 2, 3. The 4 plus 2, 6 plus 1, 7. This is 7. So the mean is 3 mu and the variance is 7. Okay. Second thing is 2x minus y. What about 2x minus y? Expected value of 2x minus y is what? 2 times expected value of x minus expected value of y. So this is 2 mu minus mu, which is equal to just mu. What is the variance of 2x minus y? This will be variance of 2x plus variance of y minus, because there's a minus sign here, minus covariance of 2x comma y, right? Now we know this is, so if 2 comes out here, it will become 4, 4 times 1 plus variance of y is just 1 minus what is, so again this 2 will come out here, 4 times covariance of x comma y, which is 1 by 2 half. So what will this become? So this is 4 plus 1, 5 minus 2, which is 3. So the mean is mu and the variance is 3. So now we know that x plus 2y is distributed according to a Gaussian distribution with mean 3 mu and variance 7, right? And 2x minus y is distributed according to Gaussian with mean mu and variance 3. These two things we have found out. Okay, cool. Now let's go to what is given to us. This is given to us, right? We are given that probability of what? x plus 2y less than equal to 3 is equal to probability of uh, 2x minus y greater than equal to 4. Okay, so what do we do about it? So what we can do is, so okay, one thing is you calculate this probability. Okay, however, calculating this probability will be very cumbersome because it will require you to, calculate the integral of a normal distribution, and you will have to do lot of rigorous thing. What you can do is you can be a bit clever and convert both of these random variables into standard normal distribution and look at the probabilities using the Gaussian integral table, because that is easier. So what I'm trying to say is just again shift and scale x plus 2y minus what is the mean of this thing, x plus 2y, it's 3 mu, right? Minus 3 mu by what is the variance? Variance is 7, so standard deviation is root 7, right? Root 7 less than equal to what? 3 minus 3 mu by root 7. This is equal to what? Probability of 2x minus y. What is the mean of this new 2x minus y? It's mu. And what is the standard deviation? It's root 3. Greater than equal to what? 4 minus mu by root 3. Right? Now, if you see, now this is like your random, standard normal random variable, right? Both of these are now your standard normal random variable. So this thing, maybe I will just write this thing is what? Probability of z, right? Less than equal to 3 minus 3 mu by root 7, and this thing is equal to probability of z, right? Greater than or equal to what? 4 minus mu by root 3. However, here it is a greater than equal to, and here it's less than equal to, right? If you want to convert this to less than equal to, just multiply both sides by minus 1, right? So this thing is equal to what? Probability of minus z less than equal to 4, 4 minus mu by root 3. Now, because of the symmetric nature of Gaussian random variable, this will just be, probability, the negative sign won't impact anything. It will still be 4 minus mu by root 3. What I have basically done here, from here to here, what I have done is you are looking at the area of z greater than equal to this thing, right? So let's see, let's call this thing something c, right? What you are looking at this area z greater than this area. What I'm saying that this thing is equal to, if this is c, look at minus c, right? Okay, I think I forgot to multiply it with minus 1. Minus, look at minus c and look at this area. So this area, this area and this area, both of them are same. That is all I have done here. So what what this equation has become is z less than equal to 3 minus 3 mu by root 7 is equal to probability of z less than equal to mu minus 4 by root 3. Okay, now now it's very simple because these two are same random variables, and we are saying that this probability is equal to, probability of less being less than equal to this thing is equal to probability of being less than this thing. Additionally, both of them are continuous random variables, so we can actually just equate these two things, the constants. So this implies, see, one thing to note here is that we are using the fact that z is a continuous random variable, because would it have been a discrete random variable, it is not guaranteed that these two things are equal. There can be multiple values of, this c and c dash for which these two probabilities can be equal. Just think about it, okay? So 3 minus 3 mu by root 7 is equal to what? Mu minus 4 by root 3. Okay, now I have to do some calculation. So this is 3 root 3 minus 3 root 3 mu is equal to root 7 mu minus 4 root 7. This thing is 3 root 3 plus 4 root 7 is equal to mu will come in common root 7 plus 3 root 3. This implies that mu is equal to 3 root 3 plus 4 root 7 divided by 3 root 3 plus root 7, and that is your answer. So again, this was a good question. I mean, decent question, I would say. So what, again, I will just recap. We knew that x plus 2y is going to be a Gaussian random variable. We calculated its mean and variance. We knew that 2x minus y is going to be a standard normal distribution, a Gaussian random variable. We again calculated its mean and variance. After calculating their mean and variance, we use the given condition that these two probabilities are same. We converted each of them to standard normal distribution for our convenience, and once they came in this form, all we did was we said that use the fact that their z is a continuous random variable, and hence the CDF at it is not possible to have same CDF at two different points. It has to be same at the same point, and hence these we can equate these two values. And we equated that, and after solving that we came up with the value of mu. I mean, it's just it's a decent question. Just think about it. Okay. Not a difficult question to tackle, but yeah, I will leave it up to you to just think about it. Okay. Let us look at another question. Let's look at question 5. So, uh, okay, so fifth question is as follows. So, x and y, it is given that they are distributed at IID according to f of x. Okay, what is f of x? F of x is a distribution which is f of x is equal to half e raised to minus x by 2, where x is greater than equal to 0. Okay, this is given to us. So basically, you are asked what is the distribution of uh, half of x minus y. Half of x minus y is distributed according to what? This is the question. So it's actually a tricky question because one might be tempted to just go and like find the distribution of this random variable half x minus y. However, there's a nice trick to it which makes it easier sort of. Okay, I will just solve it according to that trick. Can be solved according to your usual this thing. Just you can go about the CDF method. Okay, like calculate the probability of half x minus y less than equal to, let's say, some u. Okay, and you know just solve it. It's possible to do it that way. However, I will show you another method which is kind of handy and sort of helps at times. Okay, so here is the solution. So first of all, since they are IID, what is their joint distribution? F of xy of x comma y. It will just be product of each one of them, right? So it will be half e raised to minus x by 2 times half e raised to minus y by 2, and here x should be greater than equal to 0, y should also be greater than equal to 0. What is this thing? It becomes 1 by 4 times e raised to minus x plus y by 2. Okay, now actually the trick comes because here you see x plus, this is again e raised to x plus y by 2 minus x plus y by 2. However, what is asked to us is e raised to half x minus y by 2. So what you can, so here's the trick. So define two new random variables u, which is your which is what you asked for, half x minus y, and define another random variable v, which is half x plus y by 2, half times x plus y. It will become clear later why we are doing this. It's basically because this thing is v. It's like exploiting what we already have. So just look at it. I mean, it's not yeah, it's just a trick to just have in your arsenal. Okay. So if this is the case, can we find the joint distribution of u and v? Yeah, we can using transformation of random variables, right? How to do that? So for that we need to first find what is the value of x and y in terms of u and v, right? So from here, what will be the value of x? So if you add these two, u plus v, what will you get? Half times y gets cancelled, 2x. So it's simply x is equal to u plus v, right? And if that is the case, then y should be equal to what? V minus u. V minus u. Okay, just using these two, just you can just verify. That's not a big deal. If that is the case, what is your Jacobian matrix? You know, Jacobian matrix is, so this is what uh, del x by del u, del x by del, sorry, del x by del u. I think this is del y by del u, del x by del v, del y by del v. Okay, what is this thing? This matrix will, so if you differentiate x with respect to u, you get 1. If you differentiate y with respect to u, you get minus 1. Similarly, del x by del v will again be 1. Del y by del v be just 1. Okay, and this implies that mod of j is what? Determinant is 1 plus 1, which is equal to 2. Okay, so I am calculating this because I want to use transformation of random variable, right? Okay, so what will be the distribution of f of u f of u comma v of at u comma v? This will be f equal to f of x comma y at in terms of u comma v and mod j. That's all, right? So f of x comma y, we just saw it is this thing, right? And this thing is just v. So this will be what? 1 by 4 e raised to minus uh, e raised to minus v into mod j is 2. So this will become half e raised to minus v. However, we need to keep in mind that there were additional conditions, right? What were the conditions? That x small x is greater than equal to 0 and y is also greater than equal to 0. So that means this thing is greater than equal to 0 and this thing is also greater than equal to 0. So what you can do is to find the range of u and v for which this is valid, just plot these two things. Okay. So let us say you are plotting this. I hope you know what I am trying to do here. Okay. So x is equal to u plus v and y is equal to v minus u. V minus u. So this thing is true only when x and y are greater than or equal to 0. What does that translate to in terms of u and v? That we don't know. So that is what we are trying to find out. Okay. So we have to find the region where x is greater than equal to 0 and y is also greater than equal to 0. For let's say for this thing, v minus u greater than equal to 0, v equal to u is this line, right? This is v equal to u. So or in other words, this is v minus u equal to 0. Okay. So greater than equal to 0 will be this region, right? So every okay, we'll just extend it here. But yeah, that thing is just this thing. This is the region where v is greater than u. V minus u is greater than equal to 0. Okay. Let's look at the other thing, u plus. So this is u minus u plus v equal to 0. That line is this line, right? Orthogonal to this thing. And u plus v greater than, so this is u plus v equal to 0. We have to find u plus v greater than equal to 0. That line is what? That area is this region. Okay. And what is the intersecting region? That region is just this thing. Okay. whatever this region is in that I have shaded in black. That is the intersecting region, right? So for a given v, let's say for a given v, what is the range of u that you can look at? Sorry, for a given v, you can look the range of u basically goes from minus u to u, right? This is what we can see. So again, I mean, coming back to our so I have so this graph is just to come up with an idea of what is the range of u and v, which for which this distribution that we have written is true. So f of u comma v of small u and v is equal to half e raised to minus v. And what else do we know? We know that u, the range is u is less than v, right? For a given v, u has to be less than v and it has to be greater than minus v. This is what we can see, right? So you can see that u goes from, for a given v, u is between minus u and u, right? So simple thing. So okay, this is what the range of u is basically. It's because this is just thing. I mean, I hope you can see it. It's nothing difficult. So this is minus u, or you can write it minus v. This is v, right? Because it's x equal to y line, so nothing. It doesn't matter. Also, another thing is that v is greater than 0. Nothing below this x-axis is valid, right? The negative y-axis is not valid also. So v is what? V is greater than 0. This is what we know. From here, what we can do is we can marginalize out u, basically, right? So, so we have the joint distribution now. We can find the uh, marginal of u now, because that is what we had to find, right? U is because remember what we are asked for. So if we look at the marginal distribution, so we have to find fu of u, right? So let us look at the range when u is between minus infinity and 0. Okay, what is the value of that, the marginal? Fu of u will be equal to integral of this thing, half e raised to minus v dv. But however, what will be the range of v in this case? If u is going from minus infinity to 0, right? If u is going from minus infinity to 0, just look at this. U is going from minus infinity to 0. Okay, so it's basically this region. What is the value of v that it can take? It's simply at any u, it will take the value. So let us look at some u. Let's say the value of u is here. The value this can take in on y-axis is equal to what? It's equal to minus u, right? Because sorry, it's equal to u. So if you are here, you are looking at, sorry, if you are here, let's say if you are here, okay, you just look at the y coordinate, okay, and anything from there to 0 uh, is basically valid, right? Is this correct? Let me think about it. So it's, if u is between minus infinity and 0, if u is between minus infinity and 0, what is the value of v? Yeah, yeah, so it's fine. So at minus infinity, it has to be, so I hope you will agree that this goes from minus u to infinity, right? Okay, I mean, basically, u is going, okay, so u is going from 0 to minus infinity, this side, okay. What will be the value of v that it can take? So at, if you are here, the value of this is, let's say u, then the value of this is minus v, and you, if you are going here, you basically are going here, right? So this is minus u. So the value of v is going from minus u to infinity, right? That is what I have written here, minus u to infinity. And what will be this thing? So this thing, so this will become half e raised to minus v by minus 1, and going from minus u to infinity, this will become minus 1 by 2. E raised to minus infinity will be 0 minus e raised to u. This will become e raised to u by 2. Similarly, for u between infinity and 0, f u of u will become what? This will become integral half, again e raised to minus v dv. However, this time u is going from 0 to infinity. So we will go from u to infinity, right? Because now you're, so this time if you are here u, so the what is the value of v here? It is again u only, because it is y equal to x line, right? So u is going this side, so v will go from this side. So it's 0 u to plus infinity. Sorry. Okay. And this thing is equal to what? 1 by 2 e raised to minus v by minus 1, going from u to infinity. This will again be minus half 0 e raised to minus infinity 0 minus e raised to minus u, right? So this is half e raised to minus u. So f u of u is equal to what? It is half e raised to minus u for u greater than equal to 0, and it's half e raised to u for u less than 0. Okay, or you can combine this and just say that it's half e raised to mod u. Okay, minus mod u actually. Yeah. This is what it is. Okay, so yeah, so this is the distribution, and I hope you remember what this distribution is. This is your Laplace distribution, right? Okay, okay, okay. So let's look at another question, which is, again a definition question, but yeah, just a different, in just a different flavor. So let's say that x, y, z, it's a random point in a 3D coordinate system. Okay, and they are mutually independent. Okay, and so it's a 3D coordinate. Okay, and it is given to us that x, y, and z, these are distributed IID according to normal 0, 1. The question that is asked is, let's say that these 3 points are at some, what is the so basically, let's say you define a new random variable d, which is square root of x square plus y square plus z square. So basically, in the 3D coordinate, if what is the distance of the point from the origin? This is your random variable. Okay. The question is, what is the distribution of d square? D square is distributed according to what distribution? This is the question. The question again, just remember what is the, so, okay. So d square, what will that be equal to? X square plus y square plus z square, right? And we know that x, y, and z, all of them are normal 0, 1. So they are standard normal, right? And the sum of squares of standard normal is distributed according to what? They are distributed according to chi-square distribution, right? So d square will be distributed according to some chi-square distribution with degree of freedom. What? Degree of freedom DOF. Degree of freedom will be equal to what? The number of random variables. Here it was 3, so it will be 3. Again, I mean, just a definition question, but yeah, just something to remember, right? Okay. Hmm. So let us look at one last question and then we can stop. Okay. Uh, Okay, there's some charge issue. Okay. Okay. So let's look at one last question and then we can stop. It is more of a result question. I mean, you need to remember this result. It's good to remember. So there's this eighth question. There are four statements that are given to us. We will look at each of them one by one. Okay, and we'll see. We will basically we have to say tell what if a particular statement is right or wrong. Okay, if it is true or not. That's it. So here's the first thing. So x1, x2 till xk, these are some random variable. These are independent. Okay, dependent, independent. Okay, xi is distributed according to a binomial distribution with parameters ni, comma p. Okay, so it's like, so each of them, so they are independent but they are not identical. Okay, each of them have different distribution. The question is, what is the distribution of summation xi I going from 1 to k? What is the distribution of this thing? Well, whenever you have to deal with the sum of random variables, it is it is preferred to look at the moment generating function of xi. So for a binomial distribution, what is the moment generating function at a point t? That is equal to, if you remember, this is e value of expected value of e raised to txi, right? By definition. And for binomial random variable, this is equal to p e raised to t over 1 minus q e raised to t whole raised to power ni, where q is equal to 1 minus p. Okay, uh, and also q e raised to t should be less than 1. This is the MGF of a binomial random variable. So if you have to find the MGF of the summation of this xi's, the moment generating function of that summation will be the product of individual moment generating function because they are independent, right? So m of summation xi at a value t is equal to product of m xi at t I going from 1 to k. This is just due to independence, right? And what is the value of this? We know that each of them is p e raised to t upon 1 minus q e raised to t, right? And it's the product of them, I going from 1 to k and raised to ni. So this will just become what? P e raised to t. The everything in inside doesn't depend on this thing, right? I. So that will just remain. The exponents will just add up, right? Summation ni. This is what will happen. I going from 1 to k. So if you see this thing and this thing look similar. The difference is that instead of ni, it's summation ni. That means that summation xi is also a binomial random variable. However, the parameter is summation ni instead of just ni. Okay, so this parameter has changed to summation ni, and the rest of the, the other parameter remains the same. P remains the same. So what it means is summation xi I going from 1 to k is again a binomial random variable distributed according to summation ni I going from 1 to k, comma, the probability of success being p. That's all. Okay. So so this was the result for a binomial distribution. Okay, sum of binomial random variables. Let us look. So let us look at some other distribution. Okay, what about Poisson distribution? So it is given to you that x1 xi are independent I is equal to 1 to k, and each of the xi is distributed according to Poisson distribution with parameter mu I. Okay, the question that is being asked is uh, what is the summation distribution of summation xi I going from 1 to k? What is the distribution of this thing? So again, whenever you have to deal with the summation of random variables, look at the MGF. So moment generating function of xi at a particular point t, we know that that thing for a Poisson distribution is equal to e raised to mu I e raised to t minus 1. This is what this is, right? So what will be the MGF of summation xi at a value t? That thing will be equal to again product of m of xi of t I going from 1 to k. This thing will become what? Product of e raised to mu I e raised to t minus 1 I going from 1 to k, right? And what is the product of this thing? Everything is the same, just the exponent is changing, right? So that will become what? E raised to summation mu I going from 1 to k times e raised to t minus 1. So raised to t minus 1. So again, if you look at it, this thing and this thing are the same. It's just that the parameter has changed from ui to summation mu I. Okay. So you can tell from here, you can say that summation xi I going from 1 to k is again distributed according to Poisson distribution with this new parameter summation mu I going from 1 to k, right? So this is the result for Poisson distribution, right? If so basically for binomial and Poisson, this result holds that if you add a bunch of independent binomial random variable, the resultant random variable is again binomial. Similarly, if you add a bunch of independent Poisson random variables, the resulting distribution is again Poisson. However, this is not always true. I mean, just for the sake of clarity, I will just tell you that I will maybe leave it to you as an exercise that let's say xi I equal to 1 to k. These are independent, okay, and it is given to you that xi is, let's say they are distributed according to exponential. So they are also IID. Let's say they are independent as well as identical with some mean parameter. Okay, 1 by beta. Just verify that summation xi I equal to 1 to k. This is not distributed according to exponential distribution. It's not true. Instead, summation xi I going from 1 to k, it is distributed according to gamma. So it's distributed according to gamma distribution. Okay. So just be careful that this is not always true, but yeah, one thing to whenever it's true, I mean, yeah, this is how you verify the fact though. Look at the moment generating functions. Okay, so I think we'll stop here. So uh, these are all the problems that I had today to for the problem solving session. Uh, yeah, so this was sort of a short TA session because of some issues that I had. Nonetheless, yeah, I hope this was helpful and yeah, thanks for listening and yeah, see you next time. Okay, so yeah, have a nice day. Goodbye.